Now that we are done solving questions under part B of question 1, we're now going to move on to solve questions under part C of question 1. So what does part C say? Alright, so if we take a look here at the screen, we can see that the question reads, let E, which represents the universal set, equal all elements x such that x is a member of the set of integers, and 0 is less than or equal to x, and x is less than or equal to 21. Alright, and be the universal set. And then we have set A here, which equals all elements x such that x is equals to 2k minus 2, and x is less than 20, and k is a member of the set of natural numbers. Then we have set B. Set B equals 1, 3, 8, 19, 20, and set C equals 1, 2, 6, 8, 9, 11, and 15. Alright, and we can see that the instruction that we have here is that we need to illustrate this information on a Venn diagram and hence find the following sets. So we have Roman numeral 1, Roman numeral 2, Roman numeral 3, and Roman numeral 4. Okay, so we need to find all of these sets once we are done illustrating the information we've been given on a Venn diagram. So let's get started. Now, the first thing that we need to do obviously is list down the elements in the universal set E as well as the elements in the set A in order for us to illustrate this information on a Venn diagram, because we do not know exactly which elements are actually in these two particular sets. So we're going to start with the universal set E. So we're going to have E here. Alright, and now let's look at the description that we've been given of the set E. So it says all elements x such that x is a member of the set of integers. So we know that we're dealing with integers in this case. And then 0 is less than or equal to x, and x itself is less than or equal to 21. So from this, we can see that x, which represents the elements in the universal set, is greater than or equal to 0. That means that we're basically dealing with positive integers. Why? Because x is greater than or equal to 0. And then x is less than or equal to 21. So this also shows that our boundary or our limit is going to be the integer 21. So now let's get listed. But there's another point that we need to note before we can start listing down all the elements in the universal set. We are looking at inequality signs here, right? And the inequality signs that we have here between 0 and x, and the inequality sign that we have between x and 21, these are inequalities or symbols that basically illustrate that the numbers 0 and 21 also have to be part of the set. So we're going to start with 0 here, because 0 is a part of the set, and then we're now going to have positive integers all the way up to 21. So we're going to have 0, 1, then 21. This is the universal set listed out completely. Now let's move on to list down all the elements in the set A. So what description have we been given about the set A? So we can see here that A is equals to all elements x such that x is equals to 2k minus 2, and x is less than 20, and then k is a member of the set of natural numbers. So we basically have to use the equation that we've been given here in order for us to list down all the elements that are in the set A. So let's do that. We are going to have x here is equals to 2k minus 2, and then we know that k is a member of the set of natural numbers. Therefore, we can replace k with natural numbers, right? So we can start from 1 going all the way up. But remember that we have a universal set, right? Which obviously sets a boundary for us, which is from 0 to 21. Therefore, all the elements that we are going to find here that go into A have to be within the boundary of the universal set. Now, let's begin. So we can say x is equals to 2 times 1. We're going to start with the first natural number, which is 1, minus 2, and then this is going to give us, so that's 2 times 1, this is definitely going to give us a 0. So now we're going to end at 18. Why are we ending at 18? Well, let's look at one of the conditions that we've been given in the description about set A. So here we're told that x is less than 20. We're told that x is less than 20. Therefore, the last element that we are going to calculate here has to be below 20, and we can see that this element is basically 18. Our first element is 0 in the set A, and our last element in the set A is 18. So let's list down the elements now in a proper manner. So we're going to have 0, so we have 16, and finally we're going to have 18. Then we can close the set. Therefore, these are all the elements that are in the set A. Okay, so now let's begin the process of illustrating this information on a Venn diagram. We have how many sets within the universal set itself? So we can see that we have set A, we have set B, and we have set C. So we have three sets that have to go within the Venn diagram. So the rectangle that we have here is basically going to represent the entire universal set, and then the three circles that we're going to draw are going to represent the three sets A, B, and C. Alright, so we're going to have our A here, we're going to have our B here, and we're then going to have our C here. We now begin the process of illustrating the information that we have in all the sets on this Venn diagram. So the first thing that we're going to do is find the most common elements in the set A, in the set B, and the set C. So when we look around here, when we look at the elements that we have in set A, which is here, and the elements that we have in the set B and the set C, we'll see that the most common element is basically 8. So 8 is what's going to go in the middle here. It's the most common element across all three sets, A, B, and C. So now that we have that out of the way, let's find the most common element between the set A and the set B. Okay, so the set B has the elements 1, 3, 8, 19, and 20. The set A has the elements 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. So from what we can see here, the only common element between A and B is 8, and we've already illustrated 8 as the intersection of all three sets, so we cannot include it anywhere else. That means that this part here is going to be empty. Alright, so now let's move on to seeing what is common between the set A and the set C. So when we look at the set C, we have 1, 2, 6, 9, 11, and 15. So when we pay close attention to the set A and the set C, we can see that the elements 2 and 6 are present in both set A and set C. Alright, that means that these are the two elements that are common in the set A and the set C. So we're going to put them right here. So we're going to have 2 here, and we're also going to have our 6 there. We're now going to look at what's common between the set B and the set C. Set B has 1, 3, 8, 19, 20. Set C has 1, 2, 6, 8, 9, 11, 15. So we can see that in set B and set C, the only element that is common is 1, also 8 as well, though 8 we've already included it in the intersection of all three, so therefore it only leaves 1 as the most common element between the set B and the set C. So which means that our 1 is going to come right here between set B and set C. So now let's look at the elements that have to go into the individual parts of set A, the individual parts of set B, the individual parts of set C. Basically, these individual parts are the parts that are not the intersections of these sets. Let's begin with set A. So already we can see from set A that 2, 6, and 8 are gone. Therefore, the elements that are going to remain now in set A are 0, and eventually we're going to have 18 over there. Alright, so we have 0, 4, 10, 12, 14, and 16. Right, that's what we have in the individual section of set A. And then now we're going to go to the individual section of set B. And if we pay close attention, 1 is already gone and 8 is also gone. And therefore, in the individual part of set B, we're going to have 3 there. Then we're also going to have 19 and eventually 20. Alright, so that's what we have on the individual part of set B. Let's look at the individual part of set C now. Right, so when we look at set C, we know that 1 is gone, 2 is gone, 6 is gone, 8 is also gone. Therefore, we only have 9, 11, and 15 left. And now that we have illustrated all the information that is in the three sets A, B, and C, what's left is for us to illustrate the information that is outside the sets A, B, and C, but within the universal set. So if we pay close attention, we're going to see that obviously 0 is already within the three sets, 1 is already within the three sets, 2 is already within the three sets, 3 is already within the three sets. What else do we have? 4? Yes, 4 is right there. How about 5? When we look inside here, do we see 5? No, we don't see 5. So we know for sure that 5 has to come on the outside here. All right. Then let's move on to 6. 6 is right there. Do we have 7 on the inside here? Definitely not. So 7 is also going to come here. Then let's go to 8. 8 is right there. 9 is right there. 10 is right there. 11 is right there. 12 is right there. How about 13? No, 13 is not here as well. So we're going to put it on the outside of the three sets, but within the universal set. Then let's look at 14. We have 14 for sure. We also have 15. We have 16. Do we have 17? No, we don't have 17. So we're going to put 17 over here. Then now let's look again. Do we have 18? Yes, we have 18. Do we have 19? Yes, we have 19. Do we have 20? Yes, we have 20. All right. How about 21? Okay, so we can see 21 is also in the universal set here, but it's not in any of the three sets. Therefore, we're also going to write down 21 over there. So 5, 7, 13, 17, and 21 are basically elements that are not within any of the three sets A, B, and C, but are within the universal set itself. Okay, so we've basically illustrated all the information that we've been given on part C on this Venn diagram. So now the next thing that we need to do is basically find the following sets. That's Roman numeral 1, Roman numeral 2, Roman numeral 3 over here, and Roman numeral 4. So under Roman numeral 1, we have the set A complement intersection B complement. So we need to list down the elements of this particular set. So in order for us to list down or to basically find the elements that go into the set A complement intersection B complement, we need to first find what A complement is. So what's A complement? All the elements that are not in the set A. So A complement, basically you can see that we have 0 here. We have 0, so which means 0 does not come here in A complement, but 1 for sure is going to come into A complement. We have 2 in A, but we do not have 3 in A, so 3 is going to come here. We do not have 5 in A. We do not have 7 in A. We do not have 9 in A. We do not have 11 in A. We do not have 13 in A. We do not have 15 in A, and we do not have 17 in the set A. Alright, we also do not have 19 in the set A. We also do not have 20 in the set A, and we also do not have 21 in the set A. Okay, so this is what we have here with A complement. Let's also find B complement. Okay, so B complement everything that's just not in the set B. Alright, so when we look at set B here, set B we have 1, 3, 8, 19, 20. So automatically we know that 0 is not a part of set B, so it comes into B complement, and 1 is in set B, so we don't include it here, but 2 is not in set B, so it comes into B complement. Another element that will come into B complement is 4, 5, 6, and eventually 7. And then we can see that 8 is in set B, so we can't include it in B complement. However, 9 is not in B, so it will come there in B complement. Also 10 is not in set B, but it will come in B complement. 11 will come in B complement. Then we're going to have 12, 13, 14, 15, 16, 17, 18, 19. Well, 19 is in the set B, so it cannot be in B complement, so we're going to skip it. 20 is also in set B, so we cannot include it in B complement, but 21 is not in set B, therefore it's going to come into the set B complement. Alright, then we can close the set there. So now we need to look for elements that are common in A complement and the set B complement. So what's common in A complement and B complement? So when we look carefully here, we can see that 1 is not common, 0 is not common, 3 is not common, 2 is not common, 4 is not common, but 5 is common. So because 5 is common in both sets, A complement and B complement, 5 itself is going to be our first element. And then let's look again for another element. We can see that 7 is common. Therefore, our next element is going to be 7 in the set A complement intersection B complement. Let's look at 9. 9 is definitely common, so we're going to have 9 there. How about 11? 11 is also common there. Alright, so 11 is common. Then if we look carefully again, do we have any other elements? Do we have 13 there? Yes, 13 is for sure common in both sets. 15 is in both sets, yes. 16 is not in both sets. However, 17 is in both sets, as we can see there, so we're going to have 17 there. And then let's look again, is there any other element? Do we go to 19? 19 is 19 common? No, it's not common. Is 18 common? No, it's not common. 20 is 20 common? No, it's not common. But 21 is actually common in both sets. So our last element in the set A complement intersection B complement is going to be 21. Therefore, by doing this, we've basically found the set A complement intersection B complement, just like that. So this right here is our final answer on this particular question. So now that we're done with Roman numeral 1, we're going to move on to Roman numeral 2 of part C. And on Roman numeral 2 of part C, we need to find the set A union B intersection C. Very easy, right? So this is the set that we need to find. So we already know what set A is, we already know what set B is, we also already know what set C is. But what we do not know in this case is the set A union B. So we're going to have to list it down if we're going to properly answer this question. We know that set A has 0, so our first element is going to be 0. And set B also has the element 20 there. Okay, is there any other element that we need to include there? No. So just like that, we've basically listed down the set A union B. Now that we have A union B listed down, it becomes very easy for us to basically see what's common in this set, which is A union B, and the set C, which we have right here on our tutorial sheet question paper. So now let's look for the most common elements in both sets. Alright, so we can see that both sets have the element 1. Alright, so we're going to have our 1 there. Does C have 2? Yes, C has 2. Does A union B have 2? Yes, it does have 2. So we're going to put 2 there. What element is next that is common? So when we look at set C, we can see that there's 6 there. And then do we have a 6 in A union B? Yes, we do. It's right there. So we're going to write down 6 there. How about 8? For sure, 8 is definitely there. So we're going to have 8 there. Is there any other elements that's common between the two sets? When we look carefully, we have 10, 12, 16, 18, 19 here, and here we have 11, 15. No. Therefore, this is going to be our final answer. So we have found A union B intersection C, and it is equals to the elements 1, 2, 6, 8. This is our A union B intersection C. We've basically figured out and found Roman numeral 2 of part C of question 1. Okay, so now that we're done with Roman numeral 2, the next thing that we need to solve on part C is Roman numeral 3. And here on Roman numeral 3, we're being told to find the elements that are in the set A minus B union C. Okay, so we need to find the elements in this set. So but in order for us to do that, we are still going to have to simplify it. So when we simplify it, we're going to have A intersection B union C complement. All right, so this is what we have here. All right, so this is what we have here. We have A intersection B union C complement. Okay, so now that we have this, now that we have this part, it becomes easy for us to actually find A minus B union C. Alright, so now let's do just that. Okay, so if we wanted to, we can actually simplify this further by multiplying the complement with everything on the inside of these brackets here. All right, so we can say a situation where we say complement times b, it's going to be b complement, and then the union sign changes to intersection, and then our c here is also going to have a complement. So that might actually be a much longer process. So I feel it's actually much easier for us to just get the whole b union c complement and intersect it with a. All right, but in order for us to do that, we're going to have to first find what b union c is, and then find the complement of b union c, and then now intersect b union c complement with the set A in order to find the elements that are in the set A minus b union c, or the set A intersection b union c complement. So the first thing that we need to do is find b union c. Okay, so let's list down the elements in b union c, and eventually we're going to have 20. So by doing this, we've basically combined the two sets b and c. Okay, so now that we have b union c already figured out, let's find what b union c complement is. So let's find what b union c complement is. So when we look at the set b union c, alright, we can see that we have 1 2 3 6 8 9 11 15 19 20. Therefore the first element that goes into b union c complement is going to be 0. 1 does not come here, 2 does not qualify, 3 does not qualify, however 4 does qualify. How about 5? Yes, 5 does qualify as well. Does 6 qualify? No, it doesn't. 7 qualifies. 8 doesn't qualify. 9 doesn't qualify, but 10 however does qualify. 11 doesn't qualify. 12 qualifies. 13 qualifies. 14 qualifies. 15 does not qualify. 16 qualifies. 17 qualifies, 18 qualifies, 19 does not qualify, 20 does not qualify, but 21 does qualify to be a part of the set B union C complement. Okay, so we're going to close the set there. So now that we have our B union C complement, let us see what is common in this B union C complement and the set A. Right? What's common between B union C and the set A over here? Now let's list down those elements. So when we look at B union C complement, we have a 0 here. In set A, we also have a 0 there. So our first element is going to be 0 in the set A intersection B union C complement. The next common element is 4. So we're going to have 4 now because 4 is common in both sets. 10 is in both B union C complement and set A. So 10 qualifies to be a part of A intersection B union C complement. So we're going to have 10 there. Does 12 qualify? Yes, 12 is here and it's also there. Therefore 12 can be here as well. 14 does qualify because it's here and there. Alright, so we're going to have 14 here. How about 16? 16 is also going to qualify because we have it here and we also have it there. So we're going to have 16. And finally, do we have 18? Yes, we have 18 in both sets, so we're going to have 18 there, and we are going to close the set. Therefore, A intersection B union C complement is equals to 0, 4, 10, 12, 14, 16, and 18. This is our final answer. So now we're going to move on to Roman numeral 4 of part C. And what does it require us to find? It requires us to find the set A union B complement. So this is what we are required to find. This one is pretty much straightforward, honestly, because we can try to simplify it by multiplying this complement with everything inside, and we would have a situation where we have A complement intersection B complement. Alright, so all we have to do is basically find what A complement is and find B complement, and then find the intersection between the two sets, and then we're going to find our answer. It's just one and the same thing as just finding A union B complement as a whole. So the first thing that we need to do in order for us to find A union B complement is we need to find what A union B is on its own. We need to list down the elements of this set. So we're just combining set A and set B. So we're going to have our 0 there, we're going to have our 1, and then we're going to have our 2. We're also going to have our 3 there, and then we're going to have our 4, we're going to have our 6, and then we're going to have our 8, we're going to have our 10, 12, 14, 16, 18, 19, and eventually 20. So this is A union B. Okay, so now the only thing that's left here is to find A union B complement. In the set A union B, we have 0, 1, 2, 3, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20. Therefore, what goes into A union B complement is just the elements that are not in the set A union B. 5 does qualify to be in the set A union B complement. 7 also qualifies to be in the set A union B complement. 9 also qualifies to be in the set A union B complement. 11 does qualify. 13 does qualify, so we're going to have 13 there. 15 does qualify. 17 does qualify. All right, 21 does qualify. And just like that, we have found the set A union B complement. At this point, we've basically figured out all the parts under part C of question 1. Now we can move on to part D of question 1.